In this question, we're told that the product of two numbers, x and y, is 20. So we know x times y is 20. Then we take the value of x and y and we increase each of them by 30%. And we want to know the new product of x and y. So there's a few ways to approach this. And as I'll talk about at the end, this question I think is really important for understanding one of the key principles that the SAT tests in kind of a subtle way. So let's begin, though, with one approach, which is to say, well, look, if I want to increase x and y by 30%, how would I do that? Using my percent change trick, if I want to increase x by 30%, I would multiply it by 1 plus 0.30. That's a 30% increase. And similarly, if I want to increase y by 30%, I would multiply it by 1 plus 0.30. And so in other words, what I'm going to have after the change is 1.3 times x and 1.3 times y. So what we're going to do here is let's figure out what would be the product of these new numbers here. So 1.30 x times 1.30 y. Now we might say, oh, how am I supposed to get this if I don't know x and y? We'll talk more about that in a minute. But for now, if I just do a quick rearrangement here, if I go ahead and do 1.3 times 1.3, so 1.3 times 1.3, I get 1.69. And then x and y, 1.69 xy. So now think about this. We know what xy equals. We already know that the product of x and y individually is 20. So I can essentially make a quick substitution here. It's 1.69 times 20. And let's see what that's equal to. So times this by 20. And I get 33.8. And 33.8 would be the answer. Note that if you got 26 as your answer, you very likely did something like 20 times 1 plus 0.03 or 20 times 1.3. That would have worked, but for the fact that we have two numbers increasing by 30%. So yes, each number is increasing by 30%, but the product, which is the product of two numbers that have increased by 30%, must reflect that. If we just do 20 times 1.3, we actually just need to add on another 1.30 here, right? We can do 20 times 1.3 times 1.3, or 20 times 1.30 squared, and we should get the same answer. So 20 times 1.3 squared gets us 33.8. So just be careful if you've done that. We have to make sure to apply the 30% as many times as needed. So what's interesting about this question, and I think what throws people off about this sometimes, is our instinct is to get x and to get y, to figure out what is x equal, what is y equal, so that I can increase them by 30% and so that I can recreate or recalculate the product, right? So we might, in this approach, try to set up two equations. Here's one equation, and then here's the next equation. But then we get stuck because I don't know what this equals. That's the point. I'm trying to figure out what this equals. And so I don't really have two equations and two unknowns. I've got an equation and then this expression, but I can't do any kind of well, I could do a substitution, but it's not obvious how I would proceed from here if we're trying to find the value of x and the value of y. And that is because there is no value of x and value of y that we can solve for. There's no constraint beyond the fact that their product is 20 that will tell us what their values are individually. So and that's kind of the magic of the question. Even though I don't know what x equals and I don't know what y equals, I do know that the product is 20. And so before, when we found this expression, which included this product xy, we were able to substitute that fact in directly, so that even though I didn't know x and didn't know y, I'm still able to know that product. I sort of know the combination of them, even if I don't know them individually. It's kind of an interesting little, not magical, but sort of mathematical twist to this kind of question, and that gets us our answer. As a side note, because x and y are unconstrained outside of their product being 20, another approach here is just pick a value for x and y. Let's do x is 10 and y is 2, and then apply the changes, right? Let's do 10 times 1.3, and that would get us 13. And let's do 2 times 1.3, and that would get us 2.6. And so now let's multiply 13 times 2.6 to find the new product, and we get 33.8. So you could plug in any two values of x and y you'd like, as long as their product is 20, and apply the changes, and it would work as well. So just do note, this is a very common kind of principle we see across the SAT, where you may not know the individual values of x and y, and based on our math training, we're very tempted and very inclined towards finding individual values of x and y. But in some cases, you can't. In some cases, There's an infinite number of possibilities. So what we need to recognize is, though I don't have the individual values, I do know something about their combination, and I can leverage that in order to find my answers. So in this case, the answer to our question is 33.8.